Kia ora koutou, everyone. I'm Tim Hopley. I'm a senior advisor at Te Whatu Ora in the Health Protection team here in Wellington, taking over from Barry for the seminar as he's getting a tan in Cook Islands, a well-deserved break. So we're very fortunate to have Sala with us, joining us from Texas, where it's about 7 o'clock in the evening. So I'll just read your bio, Sala, and then we'll get into your presentation. So Sala works as a senior quality assurance specialist within the EPA in Kansas. You've been the lucky recipient of the US Presidential Early Career Award for Scientists and Engineers, and the recipient for State Department Embassy Science Fellowship, where you developed apps for visualizing air quality index values in Uganda, which is awesome. You hold a bachelor's degree in biomedical sciences from Texas A&M University, 2 Bachelor of Sciences from microbiology and biology from the University of Texas in Arlington, and a master's and a PhD in environmental and earth sciences from the same university. We're very lucky to have you along, and I now invite you to get into your presentation.
Okay, thank you for that, Tim. I'm excited to be here. I do have my camera on so I could say hello, but as I mentioned, I'm going to turn it off to save bandwidth, and then I will turn on my screen so hopefully folks can tell me if they see my screen here shortly. I am now sharing my screen. Can everybody see that, or just let me know if you can't see that?
Must be still loading.
Okay, let me.
How
about now? Okay.
Yes, I can see it. Go for it.
Okay, thank you for that. Thank you for that introduction. So just real quickly, yes, I'm in EPA Region 7, Kansas. I'm working virtually with them. And I have been working on visualization. I spent my whole career doing that for EPA. And so it's just very important to do this because these tools actually allow us to query different results at the same time. Does not mean or suggest that the data are related in any way. And that's a disclaimer that we actually have on one of our apps. And we tell people to note that the results should not be interpreted that way. However, they are amazingly powerful tools. And by the way, this second paragraph basically states that agencies have teamed up here in the States. So we've been working with a lot of different agencies on developing these tools, very multidisciplinary team approach, and that's wonderful. The other benefit is just noting these relationships can help address poor health and any related costs that's associated with environmental stressors. So I'm going to sort of move over to the left side of this slide. There's a lot here, but I'm going to focus on this where I'm hovered at the very bottom, this app here, this screenshot. That was the one that was done under the President's Award. I will start off by talking about that and then provide some updates. Then the app at the top, this is for noting bacterial concerns in the Gulf of Mexico, and we hope that others can sort of utilize it as well to do the same thing. And that was done under an Office of Research and Development, or ORD, funding here at EPA. And then the one on the left is the one that Tim spoke of the Kampala app that was developed. In fact, coincidentally, both of these projects started at about the same time. With the Kampala one, I was able to get them prototype. They were able to submit and get a Google grant for $1 million just months after my detail ended with them. And now they actually have an app. So that's wonderful for Uganda. And that's one of the things that I'm trying to do for these two here. So again, the environmental health and then the bacterial zones of concern tool. And I'm clicking onto the next screen. So, apps have been here for quite some time. So hats off to Zealand for doing some of the good work that they've done initially. The top here, Massey University, they've provided this tool where you're seeing one map and then the information surrounding it. And then this bottom tool is what really intrigued me back in the day when I was looking for groups that actually had these kind of tools. So where you have the two maps on either side and the information surrounding them, and then this beautiful scatter plot in the middle. So the way this works is to the bottom left, you have zeros for both of these axes. And as you go from left to right, you're going from smallest to largest. So anything high for this bottom axis is going to be to the right, and the same thing, top and bottom, anything high for this variable is going to be at the top of that axis. So if you have items that are on the top right, then that means they're high for both of those variables. So we've worked with Massey University early on that concept and incorporating in that into our tool, and you'll see that here in a bit. This is basically my dissertation. However, I finished my dissertation in 2012. 2015, I worked with several individuals to publish this. And so Mark Weber is the one who actually helped with developing this in something called micromap. So what you're seeing here, let me X out that real quick, but what you're seeing here is on the left, a map of Texas. It's color coded, so it's county level here in the States. And this left column looks at total leukemia for children 9 and under in the state. So we just aggregated it, right? And as you go from bottom left to top right, you're going from smallest to largest. This is not all of, this doesn't include all of the counties here that I'm pictured here, but this is at least for the highest ones. And if you look at road emissions and airport emissions of benzene, you'll notice they both have that general similar shape, right? One thing that we did to sort of ground truth this is we did some statistics and found there was a relationship between leukemia and airport benzene emissions. So that's one way to sort of ground truth, is to do some statistics, ground truth your tool. So it's, data quality is important. So what we've been doing, what we've been focusing on is basically linking to publicly accessible data, because we know that it's gone through some QA, QC. We're hoping, especially if it's with other sister agencies like CDC. So talking about CDC, this is their national tracking network. Several years ago, I pulled this image off of that, and this is what they had. We haven't linked to everything in here, but we've linked to a lot using what's called an API connection. So that means every time they update their information, our tools get updated without us having to do anything. And again, we're not manipulating the information, we're just linking to it. We've also linked to EPA data. One data is called EJ Screen. So that's Environmental Justice Screening and Mapping Tool that we have at EPA. Also a national emissions inventory, and I will call that NEI from here on, looking at lead, and then a national air toxic assessment, also focused on lead, and then what's called toxic release inventory, or TRI. So NEI, NADA, and TRI. You'll hear me say that later on in this presentation. We've been really, really lucky to, I give presentations all the time. I gave one at a states meeting, and Cherokee Nation leaders and representatives heard the presentation, and I offered to help them develop a tool that's very similar to our environmental health app that I'll start off with. But they said, hey, Sala, you've already done the good work in developing this tool, so we'll give you the information so you can put it in your tool. So you'll see some of that live here today in a quick demo. We've also linked to our Arkansas Department of Health blood lead levels. We pulled that into our tool, and some ozone data that was on our resident expert here in Region 6 over there in Dallas, Texas. The thing to remember is these are not the only data sets that we've linked to. We've linked to quite a bit, and that's the benefit of a tool like this, is you can do that relatively quickly, and now everybody is on the same page with that information. So this is the US Census geography. Cherokee Nation provided us lat long. That's important because with the lat longs, we can pull it into any one of these spatial layers, right? However, if you give us something in county, then we're only forced to put it here. We can't go back with that information. So they did a wonderful job by providing us that lat long, because now we have a block group, which is a smaller spatial layer, and then our census tract, and then our county, and we were able to pull their information into all three of those tools. The only tool that we actually have live is the county one. So again, I'm going to start with the Regional Environmental Health Data Visualization app. We now call it Red Viz app, and I'm going to give you a quick demo of that. Please keep in mind that Dr. Brian Chastain, he is a EPA contractor. He's the developer of this tool, and he's done a wonderful job. And then again, I'm just the spokesperson, and I am in Region 7. So let me forward on to our demo here. When the tool opens up, it has this interface. What's important to note is once you press OK, it should start. So I'm going to go ahead and start this video really quickly. There is a disclaimer at the top. We pulled this straight from CDC since we worked with them on developing this tool back in 2017. Now you can contact them. There's their email, and you can cite their work. We've updated this with other information, but that disclaimer that I read, this is it right here, right? Lets people know again, just because you see these results this way does not mean the data is related in any way. They seem to be okay with that. So you press OK, and then the tool opens up. The title's at the top left. On the right, we have that EPA logo. Click on that. It'll take you to our EPA homepages. We do have a data source tab, so you can get to our EPA environmental health page, our CDC, or that EJ screen that I talked about. You can even just email me. 3 things to do. First is optional. You can select a state by typing it in or clicking below. You have to select a variable X and then a variable Y. So what's in variable X? We have blood lead level, old homes, air quality, health, and environmental. And then we have that EJ screen. So percent of children, percent of older individuals, percent of low income, and then several other data sets that we've added here recently, like rural information, small business contracts with EPA, and then airports. So keep in mind that even the title is linked and pulled in. We're not manipulating anything. So as I hover over things, you see things pop open. That's why we use this. And this is called Click, right? It's very versatile. So I've sorted the data table, and Washington County is high there for at least Cherokee Nation lead samples that are positive for lead found outside the home. That's been aggregated from 2011 to 2020. Variable Y has the exact same variables, right? We're going to look at old homes that we pulled from CDC. So the percent of homes built between 1950 to 1979, we would expect maybe those homes might have lead, right? And so I'm hovered over the time series, and it's giving you the average. What I'm going to do here is just quickly circle the Cherokee Nation data. So you notice the areas that are white, I have not selected it, and that's outside of Cherokee Nation. So that's the benefit of using a tool like this. You can quickly hone in to the areas that you're looking at. And again, going from bottom to top is smallest to largest, and left to right, smallest to largest. So anything at the top right is going to be high for both, right? And I'm hovered over that location there in the scatter plot, and that's going to be Washington County. So as I sort through both of these variables, you'll notice there's a lot of older homes in Washington County, and the percent of lead that's found outside the home is also high for that county. I talked to the subject matter expert, and he informed me that that's the reason why they get a lot of calls from their tribal members to go and sample there. And they have been finding positive lead values, right? So I'm just hovered over so you can see that everything pops up and everything is related, right, within this dashboard. Next, what I'd like to do is I'd like to look at a different sort of data set. First, I want to let you know that we have actually updated this the dates here. So we have information from 1980 all the way to 2022. Different kinds of information. And as I hover over the trend line, you see the date 2020. So that tells you when we added this data set. We also can change the base map to add roads, streets, signs, and things like that. And also just an Esri world imagery base map. So we'll go back to the default. And I'm seeing that there might be a question, but maybe we'll get to that a little bit later. Now we're looking at lead found outside the home and lead found inside the home. And you see that that's a nicer relationship there, right? It's almost a line. So now we've moved on to a combined layer. So again, that's lead found inside and outside the home, and we're versus variable X, where we're looking at just lead found outside the home. So again, you're going to see Washington County is high for all of that. You can also loop through the years if you wanted to with this data set here. I'm going to go ahead and pause this and move on with the rest of the presentation, but this is how this tool works. And we have several tools that are like that one. This is a screenshot that I love to show. We were able to publish this, so Brian and myself, because what you're looking at here is low birth weight on the left, and then PM 2.5 annual average monitored and model that we've linked to. And what you see in the scatter plot is almost this exponential increase. So 0 to 0, 2 to 2, 4 to 4, that type of relationship. It's interesting to note that we have 3,000 plus counties in the states. And with all of those, you're seeing this relationship. Also, we have 10 different regions throughout the United States. Even the regions have this similar shape with these two variables. Also, some states do as well. The good news is we're seeing a downward trend if you look in the available years. So, and then you note the data gaps, the years that you don't have any information. And again, that's the benefit of this tool, is you can quickly and easily understand information. So we're looking at this in English. This tool can be updated so that you're now reading it in Spanish or utilizing it in Spanish. There's Maori. There are over 100 different languages, and they've recently added Luganda, or Uganda, I think is how they put it in here, which is the language that I would speak or my family speaks. The benefit of this kind of a tool is all I do is give presentations like this and note that the usage has actually gone up. So this is for that county app that I just demoed. When we first started, we had almost a flatline 0 in 2017. Now we're seeing last year predominantly just under 200. And in 2023, as we got started, we were just under 300. So there is an appetite for tools like this. This is just a quick example of the smaller sort of a drill down. This is looking at block groups, right? And we do have one that's in the middle that's census tract, but I'll go ahead and play this one so you can get an idea of what's in it as well. So again, we have that EJ screen, right? That percent low income, percent of children and older adults. We have that Cherokee Nation because they provided it at lat long. We have the TRI discharges of lead. Facility discharges of lead, public schools, NEI, facilities that emit lead, and then a NATA concentration. And we have the exact same thing for the other variable drop down as well. So what's going to happen here is we're going to hone in on Washington County, the block groups within Washington County. We're going to focus on this 2002 that I pointed to. I'm going to zoom to that right now. It's just arbitrary and random. I could have picked any other one, but you can see it's a 0.82, which is just below 0.86. So again, you're understanding the areas by zooming in, honing in, and doing things like this. So it's a 0.12 for percent under 5, and that's just under 0.17. So I'm going to sort the locations because right now it's top 5, and we're going to just zoom in to those block groups that are within Washington County. And as I do that, note that there's no particular relationship here, right? Also note this little blue dot at the bottom of the second variable where it says export tables. So you can export this and play with it in whatever tools you want to on your own. Actually all of our tools have that export button so that folks can export the information if they're savvy with GIS. And as I click on the tool, you'll notice just how quick and dynamic it is. You'll notice that the scatter plot updates almost instantaneously. There are 40 plus, I believe, block groups within Washington County, and I'm almost there. So once I click on that, now you have a clear view of Washington County. I'm going to also sort the data table, and now 2002 is the top 3 for variable Y, variable X. So what that tells you is basically we, let's see, I think my computer is going through an update. Let's go ahead and minimize that. But what that tells you is, again, that this is an extremely dynamic tool, and there are other ways of actually doing this drill down, but and for variable Y, it's now top 2. But everything updates. It's real quick and simple and easy to learn more about information using tools like this. So there are benefits to using apps, right? First, I mentioned data gaps. You know where your data is, whatever years you've collected it, and things like that. So very, very useful at a quick glance to do that. It gets all agencies on a consistent basis of communicating the information that we have, right? Those variables that we have and don't have. Also helps with prioritizing areas of interest, whether you're looking at counties within a region, within a state, agency-wide. It assists with bolstering tribal and environmental justice, community resilience, basically assists with noting those communities that are marginalized, underserved, and overburdened by pollution, irrespective of if they're in a rural area or not, or heavily densely populated area. Also helps with noting those relationships and can help address poor health, right? As I mentioned early on. I also told you about the tools, the free tools. They're all very similar, so I won't go into that bullet there. You can download the data in all 3 of them. And again, thanks to Cherokee Nation, thanks to everyone really, especially even Massey University early on for having conversations with us on how they develop their tools so that we can sort of mimic the good work that they had done. Just quick accolades. The red demonstrates about 5 years ago, maybe a little more. The green, approximately 3 years ago. So we've worked with these individuals, and then the blue just here recently. So we're getting a lot of folks who are asking us to provide presentations similar to this one from CDC. I've worked with them on radon and the radon updates. Also our tribal groups, ITEC, our different regions on adding rural or airport information, our regional science liaisons. So those are our leaders in science at EPA. Our enforcement group and our Office of Research and Development, I've given presentations with them to our GIS group. And so there's a whole host of presentations that I've been giving over the years. And I think that's really helped the conversation of visualization, at least at EPA where I work. One of the good things is this year, in March of this year, we were actually awarded some funding to continue this good work. So I'm really glad to say that we have a team of folks who will be helping with this. So Charles Lee, he's at headquarters. He's going to be helping give us the priorities that our agencies wanting to do. So that's a real important conversation that he brings to the table. Eric Hall is our principal investigator. He's really been instrumental in helping us draft all the documents that we're going to be using, our quality assurance project plans as we move forward, so that we know exactly what we're wanting to do at the end of the day. So he is our leader at ORD. and also Chelsea Berg at ORD. She will be helping us get the information out to the public and then getting their inputs and bringing that back so that we can enhance our tools. One of the main things that we want to do besides enhancing the tools functionality is also add health impact assessments or cumulative impact assessments. So Dr. Carol-Ann Gross-Davis, she's an epidemiologist in Region 3, and she'll be helping with that conversation. And then there's myself and Dr. Eleodora Chamberlain. She's also at Region 7, as I am, very instrumental in bringing us together. So she is the reason why I'm actually giving this presentation with you, and she's helped single-handedly pull all of us together so that we can get on the same page. So that's one tool that I've quickly gone over. Another tool that we've recently gotten more funding for is bacterial zones of concerns. It's called SAMI, but it helps us note hotspots of bacteria during flooding. And this was developed by ORD, the current version that we have. It's a web page based tool. In 2018, John Eastman was the developer. I've worked with Kurt Wolf, Dr. Rajbir Parmar, Dr. Mike Saiturski, myself back in the day to develop this. It's literally a shell. So I have another 2-minute video here. Again, it's called Source Assessment Mapping Interface, or SAMI. As it opens, you'll notice that we have in the middle there, we right click and we add a point, we tell it the intensity and then the distance dispersion, we give it a name, and then it pops it into the map. So that's one way to add data. There's another way that I'll show you here in a minute, but I'll go ahead and do that one more time so that you can see what that looks like. But as I hover over the area, you'll notice that the hazard danger level will change. So you're going to hover over the area of interest there. So again, I'm adding another dot. I'm telling it the intensity, how red is it? I'm telling it the distance of that dispersion, giving it a name, and then it's going to pop open on the map right there. So as you zoom in and out, you'll get a reading. It's in a logarithm. It's made up right now, but we're hoping to pull microbiological information into the tool so we can have a better understanding of how that works. So he's clicking on relative and absolute values. So it's either going to be relative to other sources or it's going to give you an absolute value as you've seen there, right? There's also an exponential or a linear value. So this would be the linear, and then we're going to switch over to the exponential here shortly. So that would be something that the user would note and actually input into the tool. So I'd like to show you how to actually go ahead and add more data. So basically it's web-based. You're going to click on he's clicking on this Excel spreadsheet. John Eastman is actually driving this video. I took it and cropped it and put it together. And so now he's adding New Orleans, right? So we can add different. That's one way to work with it. Another way is to add lots and lots of bacterial sources, places that you know are going to be prone to have bacteria. And he's done that here. And you can actually see those yellow dots, right? And so another thing you can do is you could turn off the yellow dots so that it becomes almost a heat map, right? And so the dark orange are places where you'd expect to find bacteria. So this is the second tool that we've just recently been given funding to continue. Dr. Mariosa Molina, she's a research microbiologist. She's instrumental in helping us update this tool because we need to pull that bacterial information into the tool to actually make it useful. So if folks have ideas on how to do that, please feel free to contact us. Again, Eric Hall is our principal investigator, so he's driving us, helping with organizing our team and getting us where we need to be. That funding will actually get to us in fall. So we don't have it yet, but we've been told that, you know, it's in the pipes. So we're really excited about that. So I've talked about all of this. Here's my contact information. And I just want to leave this up here so folks can see it. But we do have 2 QR codes. We do have links. I believe I can get this in a PDF form if anyone wants to, so they can play with the tools. So again, the first one is the environmental health data visualization. And then the second one is the SAMI source assessment mapping interface tool. So just some things to note. I want 3 things to note before I end this presentation. First, please contact us if you have any ideas on how to add HIAs, health impact assessments, right, to tools like this. That's important, right? So contact us about that. Also, if folks have apps, your process of updating it, we'd love to hear about that. We've actually added, again, I mentioned rural and airports, percent of airports and number of airports, and then small business funding. But our process is probably a little bit slow now that we have a larger team, at least for this environmental health data viz tool. Maybe that'll be more streamlined and a lot easier. So just wondering what folks' process is. So contact us if you have any input on any of this. And then also, we love teamwork. So if there are MOUs that we can work with folks on starting, hopefully later on this year, we will get into doing some of that. And then training. Are you providing those folks who have these kind of tools out there? Are you providing training to other agencies or your agencies or to the lay user? So those are the 3 things I want folks to kind of remember. Contact us with your comments, ideas. We love teamwork. And then training, how are you doing that? And just to leave you with something to think about. So we have weather apps. Everyone uses them, right? This is essentially the same thing. I pull up my iPhone every day to look and see what the weather is. If it's going to rain, I take an umbrella to protect myself. And so that's what I really want folks to sort of remember, is these apps are useful for at least that. And I'll turn my video on and hopefully that's working. So I can take any questions. I'm not sure if I can see the chat very well. Maybe I should stop sharing and look into that. But if there are any questions in the chat or Q&A, please let me know.
Last one, maybe. So that was, thank you very much. That was absolutely wonderful. It's definitely interactive, and I think I might have to book out maybe an afternoon so I can go and play around with it. Yeah, I think if there's any questions, just put them in the chat and we'll answer them, and turn your mic on if you so wish to have it on. I have a question to start things off. It was awesome to see you talking about lead, and I was just wanting to know, does this tool support sort of local teams going in and doing mitigation and sort of education around potential lead poisoning?
Right. So we do have one layer. It's a region 6 layer. So the region that I used to work in Dallas, Texas, and it talks about education, led everywhere they went to do outreach for education. So that sort of speaks to what you're mentioning. And one of the things that I've talked to our national lead leaders is it might be good to sort of replicate that throughout the other regions so that others could potentially put that into the tool, at least the environmental health data visualization tool there on the left. And then we would know places that we've educated folks on lead or about lead. And hopefully we'll see with respect to the blood lead levels, a decline, right? That's the whole purpose of all of this. So we're still sort of in the beginning stages. Maybe we will, I'm going to write that down. So maybe we will be able to do a little bit better on getting that information into the tool so that we can use it in that way that you're asking, Tim.
Thank you. We do have one question in the chat from Shannon. What application software is the dashboard made on?
Yes, so the one on the left, that's a great question. The one on the left is CLICK, the Environmental Health Data Visualization Tool, or the RED tool. The one on the right, the SAMI tool, that was actually, we had a programmer who sat down and developed that. And so he worked with other software engineers. And so I don't know all of the behind the scenes on that one, but he was able to sit down and develop that. Now, what I could do is actually in an email, get that off to you, Tim, later on this week, probably.
Yeah, sure. Yeah, we can do that. And maybe we can put it just on our social media or in our next newsletter.
Sounds good.
Can we open up the floor to questions? Is there any other questions from anyone? No, maybe. I think you've answered everyone's questions in your wonderful presentation.
Everybody's eating lunch, which is perfect. That works out well.
Patrick, are you seeing any questions coming through? Am I missing anything?
No, I don't see any. If there are any last questions still to come, people can either put them in the chat or the Q&A, as Tim says, or they can use the raise hand button, which ought to be somewhere along the bottom of your screen. So that'll just let us know that you've got something to ask. On the other hand, if there's no questions, and it is lunchtime.
It is, and we do have your contact information, Sala. So if there are questions from participants, then either they or we will reach out on their behalf to you.
I appreciate that. Yeah, and over the years, it's been wonderful working with Massey University. So thank you all for all that you do, for sure.
Yes, no, they are doing a wonderful job, and I think you've set the standard quite high.
Yes,
for us to do something similar. So yeah, thank you very much again, Sala.
All right,
and we'll leave you to your evening.
I appreciate it. Good day, everyone. Bye-bye.
Thank you.